Welcome to this explainer on the Introduction to Python Programming. If you've ever felt completely overwhelmed just looking at a screen full of code, let's go ahead and shift our perspective today. I want you to look at this through what we call the language builder concept. Seriously, learning Python is exactly like learning how to construct a brand new spoken language entirely from scratch. You don't start out writing Shakespearean poetry, right? You start with the basic vocabulary, the grammar, the simple sentence structures. And once you have those foundational building blocks locked in, you can program absolutely anything you want.
Okay, let's dive into this. Every spoken language needs nouns, and in our new digital language, variables are our nouns. A variable is simply a named container with a declared data type, and we use it to store information inside our program. Whenever you need the computer to remember a specific piece of data, like a user's name or maybe their high score in a game, you just pop it into a variable. Oh, and a quick note, if that data is totally fixed and is never ever going to change, we call that a constant.
So here is our roadmap for this explainer. First, we'll cover the basics of Python. Second, crunching the numbers. Third, making logical decisions. And finally, looping and repeating.
Let's kick things off with Section 1, the basics of Python.
Data in Python basically comes in a few fundamental flavors. You've got integers, which are your standard whole numbers, floats, which are numbers with decimals, and strings, which is just a fancy word for plain text. But what's really fascinating here is how effortlessly Python allows these values to morph. You can actually cast and transform data types on the fly using built-in functions. Say you have the string 12, but you need to actually do some math with it. No problem. You just pass it through the int function, and boom, it's a math-ready integer. Need it to be a decimal? Throw it in the float function and it becomes 12.0. It's incredibly fluid.
Let's see how this builds when we actually want to talk directly to the machine. A lot of times, we plan our code out using plain, everyday English, which we call pseudocode. If you look on the left, our theoretical pseudocode simply says input length, but on the right, we see the actual Python syntax for that. Length equals input, open parentheses, close parentheses. This perfectly bridges the gap between our human logic and the machine syntax. We're literally telling Python to prompt the user for an input and then take whatever they type and stash it securely into our variable container named length.
But communication is a two-way street, right? So how does the computer actually speak back to us? Well, it uses output statements, specifically the print function. It's super straightforward. You can print a direct string just by throwing it in quotes, like print text. You can print the value hiding inside of a variable just by calling its name, like print length. Or you can get a bit fancy and print a whole expression, separating different pieces with commas. So print hi name would actually output something like hi Sam. Python even automatically adds the spaces for you. It's so simple, yet incredibly powerful.
Moving right along to Section 2. Crunching the numbers. Now, alongside the usual suspects you already know, addition, subtraction, multiplication, and division, Python hands us a few totally unique tools. Now, what's really interesting about this is how it handles division. Check out the double / for integer division. If you divide using that, Python literally chops off the decimal remainder entirely and just hands you the whole number. On the flip side, the modulus operator, which is represented by the %sign, does the exact opposite. It ignores the whole number and only gives you the remainder. Oh, and if you ever need to calculate an exponent, just slap down 2 asterisks and you're good to go.
The absolute best part about all this, you don't even have to build complex math functions from scratch. Python comes packed with incredible built-in power. Need an absolute value? Just use abs of. Need to round a number to a specific decimal place? Use round of. But beyond that, Python has these massive built-in libraries you can just tap right into. You can pull from the math library for things like square roots, sines, and cosines, or grab the random library to pull a random integer using randint. The heavy lifting, the verbs of our language, they're already written for you. You just need to know how to call them up.
All right, Section 3, making logical decisions. Listen, everything, and I mean everything in computer logic hinges on one totally fundamental concept, the Boolean expression. A Boolean expression is simply an evaluation that gives you only 2 possible results, true or false. That is literally it. No matter how incredibly massive or complex an application or algorithm gets, at the micro level, the computer's logic always boils down to this simple, binary true or false choice.
So the crucial point here is understanding how we actually ask the computer these true or false questions. And this brings us to arguably the biggest misconception for beginners.
Look at the difference here. A single equal sign is an assignment operator, meaning it replaces the original value of a variable. But two equal signs side by side, that makes a relational operator that asks a question. If you type mark equals 100, you are forcefully telling the computer that the mark is now 100. But if you type mark equals 100, you are asking the computer, hey, is the mark exactly 100? To which it will evaluate and spit back either true or false.
Let's visually walk down these flowchart paths to see this in action. Think of these logic paths like a river, tracking exactly where the true and false currents flow. In a basic if-then statement, the program checks the Boolean condition. If it's true, the water flows into the then body and executes that code. If it's false, it bypasses it entirely. But if we add an else to make an if-then-else statement, we actually create a fork in the road. True executes one specific block of code, while false goes down a totally different path to execute an alternate block.
But what if we need more than two options? I mean, real-world logic is rarely just a simple yes or no, right? For that, we use a multi-way selection structure by nesting our conditions. We start with an if, and then we can chain multiple elif, which is just Python shorthand for else if, statements together. The program checks condition 1. If that's false, it drops down to condition 2. If that's false, down to condition 3, literally cascading down the flowchart until it finally finds a condition that evaluates to true or until it hits a final catch-all else statement at the very bottom. And we can get even more granular by combining conditions using Boolean logic operators, specifically and, or, and not. These truth tables outline how they combine. For an AND operator to output true, both condition X and condition Y absolutely must be true. For an OR operator, it's more relaxed. Just one of them needs to be true. And the NOT operator? It's brilliantly simple. It literally just flips the script, turning true to false and false to true. Using these lets us create highly specific, laser-focused pathways for our programs to follow. Finally, Section 4. Looping and repeating.
If logic is the brain of your code, looping is basically its superpower. It is essentially time travel and infinite automation rolled into one, and it breaks down into a universal three-step heartbeat. Step 1, check the loop condition. Step 2, if the condition is true, run the statements inside the loop body. Step 3, repeat this entire process until the condition finally evaluates to false. That three-step pulse is the core logic of all iteration.
And this brilliantly illustrates the contrast between the two main ways Python handles iteration. A for loop is exactly what you use when you want to run the loop body a very specific, set number of times. You define a starting value and an ending value, and the loop just steps through that range sequentially. But the while loop is a different beast. It evaluates a specific condition and will relentlessly run that loop body over and over and over again until that condition finally breaks and turns false.
Okay, I want to wrap up our technical content with a really cool insider trick. Some programming languages have what's called a post-test loop, often called a do-while loop, where the code actually runs first and then it checks the condition afterwards. Believe it or not, Python doesn't actually have a built-in statement for a post-test loop, but we can easily simulate it. By cleverly arranging our loop body within a standard pre-test while loop, we can force Python to behave exactly like a post-test loop. It's a fantastic example of taking our foundational grammar and using it creatively. And with that, you officially possess the grammatical foundation of Python. You understand the nouns with variables, the verbs with math, the logical branching, and the superpower of iterative loops. You've got the building blocks. So I'm going to leave you with this final thought. Now that you can actually speak the machine's language, what are you going to build? The limits from here on out are entirely up to your own imagination. Thank you so much for hanging out with me on this explainer, and happy coding!